This video covers the modification of a 5-inch gauge Winson BR1G tender into the main drive element of my 9F Evening Star. It required major modification both to upgrade the cosmetics and to fit in suitable motors. The first thing that I did was to look online to find companies that were making and selling 5-inch gauge electric locomotives to see the approaches that they were using. The most useful was Ride-on Railways. They made a loco called Hercules that used 4 Fasco 150-watt permanent magnet motors. It was shown pulling 9 people, so I realized that if I could fit 3 of these motors into the tender, and perhaps 2 in the loco, I would have more than enough torque available and could run them very conservatively for what I had in mind. This shows a 150-watt Fasco and a 250-watt Fasco on a test assembly, which will be described in Part 4. After taking a lot of measurements and examining the tender in detail, I reckon that I could squeeze 2 33 ampere-hour 12-volt batteries into the body of the tender, but the chassis would require complete disassembly and a rebuild. I've done most of my testing with just one battery installed. This shows the motor axle assembly that I finalized on. It can cover a good range of independent up and down movement, but I needed to work out a suitable gear ratio. Ride-on Railways had used a 12-tooth pinion on the motor and an 80-tooth nylon gear bolted to the inside of one of the wheels. I reckoned that I could get away with a 14-tooth pinion, but the spoked wheels would have to go. It wasn't possible to mount gear wheels on them, but as they were hardly visible, this seemed quite acceptable. 3.5-inch solid wheels were a good match and were just the right size for an 80-tooth gear. I had to make new axles and redesign the bearing block covers. While I was on, I fitted new ball races. I removed the chassis from the body and started a rebuild with the frames clamped to the bed of my milling machine to ensure that it ended up square. The Winson screws were 6BA, 4BA or 2BA, but they were very poor quality and broke easily. I replaced virtually all of them. Everything was a tight squeeze. Often I had to use countersunk screws or reverse the direction to get sufficient clearance. For many of the hexagon-headed screws and nuts, I used types with heads that were 1 or 2 sizes smaller to improve the appearance. Once this was complete, I was able to try the motor assemblies in place. It was a tight fit, but after a few modifications it all came together. The Winson suspension springs were made from strips of Tufnell, which is a resin-bonded paper. They were badly cut out, saggy and looked awful. Eventually I decided to replace them with non-functioning, rigid versions using a steel upper leaf and Tufnell below. The clamps were made of card and then soaked in superglue to turn them into a form of plastic. Rubber suspension blocks were then fitted between the bottom of the springs and the axle blocks. The rubber was made from 0.4-inch diameter black neoprene and cut to length in a special jig to ensure uniformity. This approach enabled the length to be cut to match the load by experiment. Testing on the track gave pleasing results with very smooth running, and the neoprene is not compressed with age. The bodywork required significant modification. The coal bunker had to be removed and new upper parts made. To fix these securely in place, I machined inner and outer aluminium bars which ran the internal length. It was necessary to remove the filler over the countersunk screws to fit new ones, going into tapped holes in the inner bars. Most of the front of the tender was badly made and had to be replaced. The bending at the front of the platform plate was particularly awful and looked to have been bent with a pair of pliers. The curved roof plate was also rather crude, so I made a tool with 3 adjustable rollers to curve a replacement. I made the water gauge out of some pieces cut from a foreign coin. At this stage I had not fitted the window frames. I pondered for some time how to get the wiring from the tender to the locomotive. Eventually I fitted D-type connectors at the back of each coal hole. This is the internal right-hand side. At the bottom are 2 aluminium buzz bars to which the tender motors are commoned. Above these are the reversing relays. The 2 4QD MOSFET motor drive boards are to the right of the relays, one for the tender and one for the loco. The opposite side of the tender houses the control board. Its cable length allows it to be temporarily mounted flat on top of the tender for testing. This area of the tender is covered by an easily removable plate arrangement. It's planned to cover this with coal or some equivalent. The tender plate was missing, so I made this replacement and its fittings. This shows it in place. Below the rear plate is the control panel, which will be described in part 4. The water filler cap hinges open to allow the hand controller cable to plug in. Alternatively, a special radio control unit can be connected here. The next part, part 3, will cover the locomotive itself.